Hey there, CJ Math students. Today you're on page 343. You're finally going to graduate from expressions to equations and inequalities. So an expression does not have an equal sign. It's just 3x plus 5, right? We don't know, and we're not going to solve for what x is. An equation or inequality has an equal sign or an inequality sign, and you actually are going to be able to solve for what x is using those equations or inequalities. So our first type of problem is this hanger diagram, and these are so important because this is the basis of an equation. A hanger diagram basically says that things are balanced, all right? So they're saying this side right here is equal to this side right here. Well, let's write the expression on this side. There's 1, 2, 3 x's. That means 3x. Over here there are 6 1's. That means 6. So our equation is 3x equals 6. So how can I use the diagram to find the value of x? Well, I can ask myself 3 times what is equal to 6? Or, since this is multiplication, I can do the opposite of that and divide into equal groups. So that's the answer there. Split the 6 1's into 3 equal groups, aka divide by 3. And this is kind of the basis of equations, right? When you have a coefficient, a number attached to a variable, in order to isolate that variable, to figure out just what does x equal, you undo the multiplication, you divide. So in this case, what is the value of x? If I have 3x equals 6, I undo the multiplication. 3 times what is equal to 6? I divide by 3, and this works out mathematically because 3 divided by 3 is 1, and 1 times x is just x. That's left over. And then 6 divided by 3 is 2. Watch how this makes sense. If this x is equal to 2, that means every x is equal to 2. And so therefore, if I plug in a 2 here, 3 times 2 is equal to 6. What's 3 times 2? 6. 6 equals 6. It stays balanced. You can always plug your answer back in. Let's look at another one. This time we have 3x plus 4 equals 10. Well, I would on this side I have 3x and I have plus 4. On this side, I have 10 1's, so equals 10. That's where my equation comes from. I want to isolate x. I want to get x all by itself, just like I did in the last one. So let's get rid of the 1's. I'm going to get rid of 4 1's on this side, 1, 2, 3, 4. And we're going to get rid of 4 1's on this side, 1, 2, 3, 4. Now, all I have, again, is 3 x's. 3x is equal to what's left over, 6 1's. So in this diagram here, 3x equals 6 is what you do. So how can I use the hanger diagram to find the value of x this time? Well, first, remove 4 1's from both sides, right? Whatever you do to one side, you must do to the other side. And so therefore, we're left with 3x equals 6. And just like we did in the last one, to undo multiplication, I divide. 3 divided by 3 is 1, so it's just x left over. And 6 divided by 3 is 2. Again, if I plug back in simply just for x. We know x now. X is 2. So 3 parentheses 2 plus 4 is equal to 10. Well, 3 times 2 is 6. 6 plus 4 is equal to 10. 6 plus 4 is 10. 10 equals 10. I've kept it balanced. No other answer would work. If I plugged in, let's say, pretend I just said x equals 3. 3 parentheses 3 plus 4 equals 10. Well, 9 plus 4 equals 10 is 9 plus, that's 13 is equal to 10. No, that does not work. That's the beauty of equations. You're going to get one solution to say what x actually equals. Bumping over to page 344, you're basically asking yourself, all right, if I have 4w plus 8 is equal to 32, what is this equation actually telling me? Well, 4 times what number plus 8 is equal to 32? So let's think about that. What number plus 8 is equal to 32? Another way to do that is if I have this addition, just get rid of 8 from both sides. Now I have 4w is equal to, what's 32 minus 8? 24. How did I get that? Again, if I had a hanger diagram, I'd remove 8 from this side. That gets rid of the 8 there. And I remove 8 from this side, and that makes that 24. Now, how do I solve this? 4 times what is equal to 24? I just divide by 4. And when I do that, 4 divided by 4 is 1. So w is equal to 24 divided by 4 is 6. How could I check it? I plug back in, just like I did. So if I have 4w plus 8 equals 32, anytime I see a w, I'm going to plug in a 6. So 4 parentheses 6. Always use a parentheses when plugging in. And 4 times 6 is 24. plus 8 is equal to 32. 24 plus 8 is 32. 32 equals 32. I know I am correct. If I got any other number is equal to 32, I know I'd be incorrect. Over to page 344, thinking about 4w minus 8 is equal to 32. Well, if in the last problem I subtracted 8 from both sides, it wouldn't make sense to subtract 8 from this side, because if I subtract 8, that's not going to make that 0. A negative 8 minus 8 is actually a negative 16. So this time I'm going to add 8 to both sides. That gets rid of that. Negative 8 plus 8, that's a 0 pair. So I get 4w is equal to 40. How do I know that? Because it's saying 4 times what number minus 8 is equal to 32, or what number minus 8 is equal to 32? 40 minus 8 is equal to 32. And that's why I know I can set this up as 4w is equal to 40. So what's the value of w? W is 10. How do I know that? 4w is equal to 40. Again, if I see multiplication, I simply divide, and I get w is equal to 10. How do I know this is true? Plug it back in. 4w minus 8 equals 32. Instead of a w, I plug in a 10. 4 times 10 is 40. Minus 8 is equal to 32. What's 40 minus 8? It's 32. Does 32 equal 32? Sure does. Make sure you got all this writing down. You can close your Chromebook and ask for the exit ticket.